You start an AI coding session, and the first few prompts work perfectly. But by turn 25, the model loses your architecture, forgets your initial goals, and the logic collapses. Developers call this vibe coding, guessing your way through a messy web of disconnected chat logs. Google's Gemini Conductor replaces that chaos by storing your project's architecture and logic as permanent markdown files directly inside your repository. We are going to take an empty workspace and turn it into a context-driven AI environment that plans, builds, and remembers its own work, all in under 5 minutes. Before we start, you need 3 things: your terminal access, the Gemini command line interface installed, and your code editor open. Storing your development history in version-controlled text files provides the AI with a persistent memory of your technical decisions. Set up your workspace by placing the terminal on the left and code directory on the right. Run the install command for the Conductor extension, using the auto update flag to ensure you pull the latest framework. Next, type /conductor setup. This command initializes the foundational memory bank for your project. The CLI will ask you to define your target users, your technology stack, and your testing rules. Your answers form the baseline instructions the AI will read before starting any new task. Watch the directory. Conductor generates a folder containing your core memory, a product document, a tech stack file, and workflow rules. Inside the product guidelines, explicitly list actions the AI must avoid, like using deprecated libraries or bypassing security checks. Restricting the AI's options through these negative constraints creates a rigid logic gate, which results in more stable analytical code than a list of broad positive permissions. To build a specific feature, like a client reporting dashboard, Conductor isolates the work into a unit it calls a track. Type /conductor/new track and provide a short description of the feature you want to scope out. This generates 2 critical artifacts: a specification sheet outlining exact requirements, and a plan document breaking execution into a step-by-step checklist. Stop and read the generated phases. This is your opportunity to verify the logic and correct misunderstandings before code is written. By forcing the AI to draft an explicit checklist and wait for manual approval, you actively constrain its execution path and prevent scope creep. With the plan approved, type /conductor/implement to hand control over to the agent. The AI reads your plan, selects the first pending task, writes the necessary code, and runs tests against your workflow rules. This diagram illustrates the system in motion. The AI completes a specific task on the list, and the corresponding code file instantly populates in your editor. As long as the instructions in your plan remain unambiguous and the test's tasks, the model will continue advancing through the checklist without needing further prompts. You monitor this progress by running /conductor status to get a high-level overview of your active tracks. Automated execution is rarely flawless. A logic error or a broken function will eventually occur during a complex build. When that happens, type /conductor revert. Conductor uses Git history to roll back the exact logical phase that failed, bypassing the need to hunt down raw commit hashes. Linking your version control directly to these logical tracks provides a predictable method for managing autonomous AI generation. This UI mockup shows our final result: a functional client reporting dashboard, complete with data charts and authentication elements, built by following the approved plan. In the project root, you have a permanent record. Every decision, workflow state, and completed phase is documented in Markdown. If you step away for a month, context remains intact. The AI reads the directory and knows exactly where it left off. For your next step, run the setup command inside an existing, older repository. This forces your team to extract their implicit knowledge into an explicit, shared memory bank. Moving development context into your repository enables you to manage AI as a structured system, using approved plans to drive autonomous builds to completion.